In this video, we're going to look at a more theoretical example of the convergence of a power series. The question here we have is, assume that summation n equals 0 to infinity c sub n x to the power of n converges when x equals -5 and diverges when x is equal to 7. What can you conclude about the convergence or divergence of the following series? Question A, summation n equals 0 to infinity c sub n. Question B, summation n equals 0 to infinity c sub n times 5 to the power of n. Question C, summation n equals 0 to infinity -1 to the power of n times c sub n times 9 to the power of n. Question D, summation n equals 0 to infinity c sub n times -4.9 to the power of n. When you see a question like this, it's kind of theoretical. The first thing you should do is think about what value of x do we have to plug into the power series to produce the series that we're given. For question A, what value of x should you plug in to obtain summation n equals 0 to infinity c sub n? Clearly, plugging x equals 1 gives us question A. Now, for question B, what value of x should you plug into the power series to obtain question B, summation c sub n times 5 to the power of n? Clearly, plugging x equals 5 gives us question B. Now, question C is a little bit trickier. What value of x do we plug into the power series to produce summation n equals 0 to infinity, -1 to the power of n, c sub n times 9 to the power of n? If we do some algebra and rewrite this series as summation n equals 0 to infinity minus 9 to the n times c sub n, clearly we plug in x equals -9 into the power series to obtain question C. Now, question D. What value of x do we plug into the power series to obtain question D, which is summation n equals 0 to infinity c sub n times -4.9 to the power of n? What value of x do we plug in? Clearly, we plug in x equals -4.9 into the power series, and the power series reduces to what we have in question D, summation n equals 0 to infinity c sub n times -4.9 to the power of n. Now, let's look at question A first. Here we have summation c sub n equals 0 to infinity. Let's first start by identifying the center of the power series. So we have summation c sub n x to the power of n. This is the power series. And the center is clearly x equals 0. The interval of convergence of this power series has the pattern minus a, comma a. It has the form minus a, comma a. Now, we know that summation c sub n x to the power of n equals 0 to infinity converges at x equals -5. That means the radius of convergence must be at least as large as 5. So the given series, summation c sub n x to the power of n equals 0 to infinity, converges for all values of x in this interval from -5 to 5. So converges for all x in this interval. Now plug x equals 1 into the power series into summation n equals 0 to infinity c sub n x to the power of n, and we get summation n equals 0 to infinity c sub n times 1 to the power of n, and we simply get summation n equals 0 to infinity c sub n. Now, x equals 1 is inside this interval, inside the interval of convergence from -5 to 5. If we draw a diagram, here's the interval of convergence from -5 to 5. I'll put a solid circle here because we know the power series converges at the left endpoint x equals -5. X equals 1 is here. Sorry, x equals 1 is here. And it's inside the interval of convergence because the power series converges in this interval from -5 to 5. And x equals 1 is inside this interval, then of course that means that summation c sub n equals 0 to infinity converges. All right, let's look at question B. Now, we know that summation C sub n, x to the n equals 0 to infinity, converges for all x in the interval -5 to 5. So the radius of convergence must be at least as large as 5. Now, we don't know anything about the convergence of a power series at an endpoint. So summation C sub n times 5 to the power of n may converge or diverge. We simply don't know. Because if we look at our interval, we know that the power series converges at x equals -5. So the radius is at least as large as 5. So this is the radius of convergence. Radius is 5. The interval of convergence is from -5 to 5. But we don't know what happens at the endpoints. We know that the power series converges at x equals -5, but we don't know anything about what happens at x equals 5, at the right endpoint. We don't know. So the ratio test that we do doesn't tell us what happens at the endpoints. Those endpoints have to be plugged into the power series separately, and then we have to do a test of convergence. Of course, in this case, because it's a theoretical example, we can't do that because we don't know the details of the power series. All we can say is that we don't know what happens at the right endpoint. So we really have two possibilities. We have -5, 5 for our interval of convergence, or -5, 5. Notice that in this case, we have a square bracket. That means we include the left endpoint, but we exclude the right endpoint because in this case, the power series diverges at the right endpoint x equals 5. In this case, the power series converges at x equals 5. And we could both are possibilities. We simply don't know. So we can't conclude anything about the convergence. So let's write that down. We cannot conclude anything about the convergence of the series summation n equals 0 to infinity C sub n times 5 to the power of n. All right, let's look at question C. Here we have summation n equals 0 to infinity -1 to the power of n times C sub n times 9 to the power of n. Now let's look at this, the center of this power series. So we have summation C sub n x to the power of n equals 0 to infinity. The center is clearly x equals 0. We know that this series summation C sub n x to the n equals 0 to infinity converges at x equals -5 at the left endpoint. But it diverges at x equals 7. So let's draw a diagram. If we draw a diagram, we know that this power series converges in the interval from -5 to 5. And here is the center 0. We know that it diverges outside this interval. So let's write this down. Converges when x is between 5 and -5. Diverges when x is bigger than 7 and when x is less than -7. So diverges here. Diverges when x is larger than 7 and diverges as well and diverges when x is less than -7. Diverges when x is less than -7. So the radius of convergence must be larger or equal to 5. It is at least as large as 5 and less than or equal to 7. It must be smaller than 7 because the series diverges at x equals 7. So now let's plug in let's plug in the value of x that produces the power series that we have, the given series that we have. We have summation n equals 0 to infinity c sub n, negative 1 to the power of n, c sub n times 9 to the power of n. What value of x do we plug in? So let's rewrite this as n equals 0 to infinity and c sub n times, and let's combine these two. We have the same exponents, so we can just combine the bases and we get minus 9 to the power of n, just a little bit of algebra. So what value of x do we plug in? Clearly, x equals negative 9. If we plug in x equals negative 9 into the power series, n equals 0 to infinity, c sub n, x to the n, we're going to get summation n equals 0 to infinity minus 9 to the power of n, x to the power of n, and a bit of algebra, and we will get question C, negative 1 to the power of n times 9 to the power of n times x to the power of n. So clearly, plugging x equals negative 9 gives us that power series. So we have to ask ourselves, is x equals negative 9 inside the interval of convergence, or is it outside the interval of convergence? Well, it's clear. X equals 9 is here. Here's x equals 9. X equals 9 is here. Is clearly the power series is divergent when x is bigger than 7. So since x equals 9 is outside the interval of convergence, the series will diverge. So x equals negative 9 is outside the interval minus 7, comma 7. The given series summation n equals 0 to infinity, negative 1 to the power of n, c sub n, 9 to the power of n, diverges. Now, this is very important. I just want to look at this diagram again just to show you. So basically, when you draw this diagram, you know the values of x for which the series converges. We know between negative 5 and 5 for sure the series converges. We also know that this series diverges at x equals 7. That means for any value of x bigger than 7, the series diverges, and for any value of x less than minus 7, the series also diverges. And here we have x equals negative 9. So I just need to make a correction. Minus 9 is here. There's minus 9. I put 9 here, but we're actually looking at x equals negative 9. So x equals negative 9 is outside the interval of convergence. You can see it belongs to the red zone of divergence. X equals negative 9 is less than minus 7. So for that reason, this power series diverges at x equals negative 9. So diverges at x equals negative 9 is outside this interval. All right, let's look at question D. Here we have summation c sub n times negative 4.9 to the power of n. Now the center of this series, like before, is simply x equals 0. So n equals 0 to infinity, c sub n, x to the power of n. The center is x equals 0. Now we know that summation n equals 0 to infinity, c sub n, x to the power of n, converges at x equals negative 5. Converges at x equals negative 5. So the radius must be at least as large as 5. So r is larger or equal to 5. So the power series must converge for all values of x in the interval negative 5 to 5. So here's the power series, here's the diagram. So from negative 5 to 5, the power series must converge in this interval. Now let's plug in x equals negative 4.9 into the power series, into summation n equals 0 to infinity, c sub n, x to the power of n, and we obtain summation n equals 0 to infinity, c sub n, times negative 4.9 to the power of n. Now, the power series converges in this interval. Converges. We also know that the power series converges at x equals negative 5. So let's make it a solid point, solid circle. Now, the question is, where is x equals negative 4.9? Well, x equals negative 4.9 is inside this interval, right? So x equals negative 4.9 is inside the interval -5 to 5. For that reason, summation n equals 0 to infinity c sub n times -4.9 to the power of n converges. Because the value of x, which is -4.9, is inside the interval of convergence. We know that the power series converges in this interval when x is between 5 and -5. All right, thanks.